Hello students, today's topic is multiplication product. So now multiplication product is of two types, scalar product and the second one is vector product. It's also named as cross product. And scalar product is also known as dot product. It can be represented as A dot B and the vector product is represented as A cross B. The formula of scalar product is magnitude of A, magnitude of B, cos of theta, and its formula is magnitude of A, magnitude of B, sine theta n cap, and n cap is the direction of the vector. Now here are the some properties of scalar product and the vector product. Firstly, we discuss about the properties of scalar product. So the first one properties of the scalar product is commutative. Scalar product is commutative. So it means A dot B is equals to B dot A. So now A dot B is, we know that A magnitude of A, magnitude of B and cos of theta. But if we talk about B dot A, then it will be become magnitude of B, magnitude of A and cos of B dot A. Here the theta is the dot product of the angle between them. So B dot A. So here will be B, magnitude of B, magnitude of A and cos of minus theta. And cos of, we know that cos of minus theta is equals to cos of theta. So B dot A becomes magnitude of B, magnitude of A, cos of theta. So A dot B is equals to B dot A. Second property is scalar product of two parallel collinear vectors. If two vectors, for example A dot B, A and B, if A and B two vectors are parallel and collinear, then if these two vectors are collinear, then the angle between them is 0. And we know that cos of 0 is equals to 1. So A dot B is equals to magnitude of A and magnitude of B. But we also know that these both of the vectors are parallel, so their magnitudes are same. So A dot B is equals to magnitude of A ka square. Here we can say that vector of A is equals to vector of B, and we can write dot product of same vectors are the magnitude square of its magnitude. Now the third property is scalar product of two vectors. If we do the scalar product of two vectors of which are perpendicular to each other, so the angle between them is 90 degree, and we know that cos 90 is 0. So the scalar product of two perpendicular vector is 0. Now the fourth property is scalar products of unit orthogonal vectors I, J, K. So if I dot I, then the angle between them is 0, and if we talk about I dot J, then the angle between them is 90 degree. So we know that if the angle between the two vectors is 90 degree, then the answer will be 0, and if the angle between similar vectors is 0, then the answer will be 1. So the product of I dot I is equals to 1 and I dot j is equals to 0. So the fifth one property is scalar product is distributive, which can be written as A dot B plus C is equals to A dot B, and A dot C is under addition. So now we talk about the important properties of vector product. So the first one property is vector product is anti-commutative. Anti-commutative. It means A cross B is equals to minus B cross A. And this is because in the formula we written as magnitude of A, magnitude of B, sine theta n cap, and if we do B A cross B and B cross A, then the direction will confirmly change, and for the direction here is the negative sign we have. Now the second property is area of parallelogram. So from vector product we can find out area of parallelogram, which is equals to magnitude of A vector cross B vector. And third one property is area of triangle, from which we can also find out the area of triangle, which is half of magnitude of A cross B. And now the fourth property is vector product of two collinear vectors. So if two collinear vectors will be producted, then the angle between them is 0, and we know that sine 0 is equals to 0. So vector product of two collinear vector is 0. It means A cross B is equals to 0 because sine 0 is equals to 0. And now the fifth one property is cross product of two perpendicular vectors. If we do the cross product of two perpendicular vectors, then the angle between them is 90 degree, and we know that sine 90 is equals to 1. So if we put the value in the formula, then sine 90 is equals to 1. So it can be magnitude of A, magnitude of B. So the cross product of two perpendicular vectors is equals to A cross B is equals to magnitude of A and magnitude of B.